Hello everyone, in this video we'll be doing some exercise questions, that is exercise 13.4. The 13.4 the question is write the IUPAC names of the products obtained by the ozonolysis of the following compounds. Now the first one is pentene. Now what is ozonolysis? In ozonolysis of alkenes, EN, therefore this is an alkene, the carbon to carbon double bond. Ozonolysis of alkenes involves the addition of ozone molecule to an alkene to form ozonide. Ozonide is formed first, and then cleavage takes place by zinc in water to smaller molecules. Now this reaction is a very useful reaction in detecting the position of the double bonds in alkenes. Now let's check how ozonolysis takes place in pentene. Now pent means 5 carbon atoms, 1, 2, 3, 4 and 5 carbon atoms. Therefore if this is carbon number 1, 2, 3, 4 and 5, double bond would be here. Therefore add carbon atoms CH, H, H2 and then H3. Now when it reacts, it will react first with ozone. We will be getting an ozonide molecule. Now both the bond breaks here will be therefore CH, these are CH3. Now this is the case. Now the O3 would come and attach here, O, and then from here CH, CH2, CH3. Now this is the way, this is an ozonide. An ozonide molecule is formed in this way. Now a short trick method here is, now before going into that, let's first obtain the product here. Now when it reacts, cleavage takes place in the presence of zinc in water. Zinc in water, it will take place. Therefore the breakage of this bond breaks up in this way. Therefore this oxygen is taken by zinc and there is removal of zinc oxide. Zinc oxide is removed and then you'll be getting here CH3, CH. The first molecule will be CH3, CH, double bond O, CHO, and aldehyde, and the second molecule will be CH3, CH2, CH, double bond O. Therefore we'll be getting here an oxygen two bonds breaks up in this way. Therefore there will be, since two bond breaks up, a double bond character would be obtained here and then in this way. Therefore here, and the IUPAC name is here when ethanol is produced. This is an ethanol and then this is propa. Now the ethanol aldehyde group propanol is produced in this way. This is the process in which ozonolysis takes place. Now a short trick method on how to understand ozonolysis is, I've explained this while explaining the chemical reactions of alkenes, but let me explain it again. Now if this is our alkene molecule, let's take a simple alkene. Now just add double bond O in this way, break the bonds in this way. Therefore add this oxygen to this oxygen to this. Therefore we'll be getting a CHO and then a CHO, two molecules of formaldehyde in this way. Now when we take another case here, the products that is formed, another case for this is a short trick method for how ozonolysis would take place. Now CH3, CH2, okay, CH and then CH3. Now ozonolysis, an example, the product here also undergo ozonolysis. In the product here will be CH3, CH3, CH, double bond O, it will be for this will be produced, and then even in this case CH3, CH3, CH, double bond O would be produced. Therefore in each of these cases ethanol is produced in this case. Therefore this is a short trick method on how to understand ozonolysis takes place. Now let us do one more example. The second example is 3,4-dimethyl hep3ene. Now hep means 7 carbon atoms, 1, 2, 3, 4, 5, 6 and 7 carbon atoms. Now the triple bond the double bond is in carbon number 3, 1, 2, and 3. Therefore 1, 2, and 3, our double bond would be here, and then 3, 4, 1, 2, 3, 4, 5, 6, 7, and this dimethyl group, the two methyl groups are attached to carbon number 3 and 4, CH3, CH3. Now add carbon atoms, H3, H2, 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 H3. Therefore, this is our 3,4 dimethyl, have 3 in. Now, when it breaks with ozone, O3, we will be getting our O3 would attach to this double bond, breaking the double bond here. We therefore would be getting CH3, CH2, C. The ozone, these are carbon, C, H2, CH2, CH3, the 3 ozone, and then our substituent CH3, and then this substituent, let's write here in this way. This is an ozonite molecule. Now when it reacts with zinc in water, there will be cleavage, breakage of bond, breakage of 2 bonds, means this bond for this side and then this bond for this side. Now the molecule would split into 2 in this way. Therefore this oxygen would be taken by zinc to release, zinc oxide is released, and therefore we'll be getting, now for this side, if we consider for this side, now leaving out that side, we CH3, CH2, C, our substituent is here, CH3, and then double bond O would be attached here. Now and for this side, plus CH3, CH2, CH2, C, our substituent CH3, double bond O. That is the way in which ozonolysis takes place. Therefore, this is 1, 2, 3, 4, 4 carbon atoms, 1, 2, 3, 4, 5 carbon atoms. Now 4 carbon atoms is this. Now we have here carbon number 1, 2, 3, and 4. Therefore, this is known as 4 carbonous but 2 on, and then this would be known as 5 carbon atoms. Therefore, pent 1, 2, 3, 4, and 5. Pent 2 on, penta, this AN. Therefore, since this is S, and therefore this is pentane 2 on. Since this is a single carbon to carbon bonds, therefore we can utilize the pentane 2 on, or this would be known as butane 2 on. Therefore, this is the way in which ozonolysis of alkene molecule takes place.